Hi everyone, today we'll be looking at the June 19 paper 3 calculator paper of the GCSE. So question 1, we're being given this Venn diagram. Set A has 1, 5, 6, 8 and 9, that's the elements of A, and B has 2, 6 and 9. And we're being asked to complete the Venn diagram to represent this information. Obviously, I will start off by identifying the elements that are common to both A and B. They are 6 and 9. So 6 and 9 go in the common region. And then I've got the 2 here for B, the 1, the 5, and the 8 in A. And then I need to take into account the universal set that has the first 9 positive integers, which means that 3, 4, and 7 need to appear outside of A and B. Now, a number is chosen at random from the universal set. Find the probability that this number is in the set A intersection B. Remember that this symbol, the intersection symbol, simply translates into A and B. And we've got 2 elements in A intersection B out of a total of 9, so that's going to be 2 over 9. Question 2, we've got Katie that invests £200,000 in a savings account for 4 years. The account pays compound interest at the rate of 1.5% per annum. And we need to calculate the total amount of interest that she will get at the end of the 4 years. Let me start by highlighting that we want the total amount of interest, not the total amount of the investment. So we will start by calculating the total amount of the investment at the end of these 4 years. Now, we've got an initial amount of 200,000, which increases by 1.5% per year. The multiplying factor associated with this percentage increase is 1.015. And I have to raise this to the power of 4 because this will happen for 4 consecutive years. Plugging all of this on the calculator is giving me 212,272 and 71 pence, and this is the total amount of the investment. If I deduct the 200,000, I get the 12,272.71, which is my final answer for question 2. In question 3, it's the height of 80 plants, and we need to find the class interval that contains the median. It's always a good idea in these cases to start by adding an extra column of cumulative frequencies, which really is a running total. So I've got 7 people between 10 and 20. I've got 20 people up to 30. I've got 20 plus 14, 34 people up to 40, 46, 62, 80. So always check that the last entry in the cumulative frequency column is actually the total number of items in the study. Now, to find the class that contains the median, I will start by dividing my total by 2, which is 40. So I'm pretty much asking where is the 40th observation. Now, the first 34 observations are up to 40. And the first 46 observations are up to 50, which means that the 40th observation is to be found here between 40 and 50. And then part B, we need to draw a frequency polygon for the information in the table. We always plot the frequencies against the midpoints of each class. So the 7 here for the first class will be plotted against 15, the 13 against 25, and so on. So 7 against 15, then it's gonna be 13 against 25, then it's gonna be 14 against 35, and we're back down to 12. And then it's gonna be 16 for 55, and finally 18 for 65 to 70. Remember, I need to join these with straight line segments in order to construct the frequency polygon. And that's it. In question 4, someone drew a time series graph, and it's the number of visitors in thousands against the year, and we need to write down 2 things that are wrong or could be misleading. So there are things that are wrong here, and there are things that are misleading. So if we just look at the graph here, the first thing that I see that the y-axis, the vertical axis, does not start from 0. So that's something that could certainly be misleading. So vertical axis does not start at 0. If I just stick on the y-axis for a moment, I see that I go from 6, 6.5, 7, 7.58, 8.59, and then 9.5 is missing. That is certainly wrong. The scaling is wrong. So 9.5 is missing from the y-axis. And another thing someone could say is that the points have not been joined with straight line segments. That should be the right thing. And the person who drew this time series graph just joined them with a curve. So that could be an additional point. I could call it point 3 here, that points have not been joined with straight lines. Moving on to question 5, we've got a hexagon. It has one line of symmetry. Obviously, it's the line going through the middle here. So FA and BC are shown to be of equal length. Similarly, EF and CD are of equal length. And angle ABC is 117. Angle BCD is twice angle CDE. And we're being asked to find AFE. AFE. I will start by calling the angle here X. And they must be the same because of the line of symmetry. It also means that the angle FAB here should be 117 as well because of symmetry. And then using the fact that the BCD, this angle here, is twice CDE, it means that this here is 2x and this is also 2x, again because of symmetry. Now, it's a hexagon, and we know that the interior angles of a hexagon can be found by multiplying 6 minus 2 times 180. So a hexagon can be split into 4 triangles, each triangle contributing 180 degrees to the interior angle sum, and I could then identify the 6 angles. It's 117 plus 117 plus 2x plus x plus x plus 2x. It's always a good idea to check that you've got 6 angles, so 2, 4, 6. So everything seems to be there. 4 times 180 is 720, and on the right-hand side, 117 and 117 is 234 plus 6x. And I'm going to do 720 minus 234 is 6x, leading to 486 is 6x. Dividing by 6 gives me that x is 81, but remember, we were not asked to find x, we were asked to find AFE. AFE is 2x, so AFE is 2 times 81, which turns out to be 162 degrees. Question 6, it's Jeremy who has to cover 3 tanks completely with paint. Each tank is in the shape of a cylinder with a top and a bottom. The tank has a diameter of 1.6 meters and a height of 1.8 meters. He has 7 tins of paint, each one covering 5 square meters. And the question is whether Jeremy has got enough paint to cover completely the 3 tanks. I will start this question by saying that the radius of this cylinder is 0.8 meters, half of the diameter. And I'm going to calculate the total surface area, which is of this cylinder, which is the curved surface area 2 pi r h plus the top and the bottom 2 pi r squared. Notice that we're talking about 3 tanks here. This expression here corresponds to 1 tank, so I'm going to multiply this by 3. And if I plug everything on the calculator, I get 31.21 square meters. Now, how much paint does Jeremy have? Well, he's got 7 tins, and each tin can cover 5 square meters, so he can cover 35 square meters. 35 is obviously less than 39.21, and therefore there is not enough paint. Question 7, we need to work out the value of 2.5 times sine of 43 over 8.2 squared minus 50.5 all square root. This is a classic calculator question. You just plug everything carefully on the calculator just like you see it, and be careful when to give answer correct to 3 significant figures. It gives me an answer of 0.319. And then 8, ABC is a right angle triangle, and AB is 6 centimeters, AC is 8 centimeters, and Sarah has provided this working out to find BC. What's the mistake that she made in her method? Well, if you look at her method, she said that BC squared is AB squared plus AC squared. We know that Pythagoras says that the hypotenuse squared, and this is the hypotenuse, it's the longest side, it's the side that's found opposite the right angle, it is the side that never touches the right angle. And obviously this is the mistake that Sarah did. She used BC as her hypotenuse where it was actually AC. So the mistake she did is that she has used BC as the hypotenuse instead of AC. That was part A. Now, in part B, we've got Roy, who has an enlarged triangle PQR, center C, scale factor 1.5, and he ended up with triangle XYZ. Obviously, the original thing is the object, and the final thing is the image. And we're being told to explain why Royce's diagram is not correct. Now, we know that the scale factor is image over object. So I'm just going to take a length on the image and find the corresponding length on the object. So if I do image over object, I should be finding the scale factor. In our case, I'm going to consider xy, and the corresponding side is PQ. So if I do xy over PQ, well, obviously xy has a length of 5 units and PQ a length of 2 units, which is 2.5, which is not equal to 1.5. So scale factor is not 1.5. That's the mistake that Roy did. He has actually enlarged by a scale factor of 2.5. Number 9, we've got a company making a large number of boxes. They have 6 machines all working at the same rate. When all the machines are working, they can make all the boxes in 9 days. And this table gives the number of machines working each day. And we need to work out the total number of days taken to make all the boxes. So It has to be clear here that even though we've got 6 machines in total, not all of these machines are working each day. So we had on day 1, we have 3 days. On day 2, 4 days. And day 3, 5 days. 4 machines, on day 3, 5 machines. And on all remaining days, it was 6 machines. Okay? So if all 6 machines were available for all days, we will need 9 days. So I will start by saying 6 times 9, it's 54 machine days needed in total to finish the job. Obviously, machines and days are inversely related because the greater the number of machines, the less the number of days needed. And if you think about it, up to now, we had 3, 4, and 5. We had 3 plus 4 plus 5 equals 12 machine days. And 54 minus 12 is 42. We've got 42 machine days with 6 machines available. So this means that we need an extra 7 days, so 42 over 6. We need an extra 7 days to finish. So in total, because it's the total number of days needed here, 7 days is the number that goes here. And we had the 3 first days where we had parts of the machines working. So in total, it has to be 7 plus 3, which is 10 days. So that was question 9. Question 10, it's Marie, who is investing 8,000 in an account for a year. At the end of the year, we've got interest added. Marie pays tax on this interest at the rate of 20%, and she pays 28.80 in tax. What is the percentage interest rate for the account? So, I don't know the interest rate. I'm going to start by calling this R percent. And she invested 8,000. She received interest of R percent. So 8,000 times R over 100 represents the interest, the total interest in a year. And on the total interest, she's paying 20% of that in tax. So if I multiply this by 20 over 100, that will be the tax paid, which we've been given to be 28.80. Now, obviously it's a simple equation in one unknown R. I'm going to do 8,000 times 1 over 100 times 20 over 100. I get that 16R is 28.80. I divide both sides by 16. R is 1.8. And therefore, the interest rate is 1.8%. 11, in May 2019, the distance between Earth and Mars was 3.9 times 10 to the 7 kilometers. And we have sent a signal from Earth to Mars, traveling at a speed of 3 times 10 to the 5 kilometers per second. How long did the signal take to get to Mars? Now we know that speed is distance over time. We have the speed, which is 3 times 10 to the 5, that's kilometers per second. It's a good idea to include the units. The distance is 3.9 times 10 to the 7 kilometers. And I want to find the t in seconds. So in order to find t, I will cross multiply. So 3 times 10 to the 5 times t is 3.9 times 10 to the 7. So t is 3.9 times 10 to the 7 over 3 times 10 to the 5, which I'm being told is 130 seconds by my calculator. And then the speed of the signal sent from Earth to Mars was actually less than 3 times 10 to the 5. How will this affect your answer to part A? So if the signal was actually slower than what we have anticipated to be in our calculations here, it will obviously take more time to reach Mars. So since the speed is less, the signal will take more time than 130 seconds. So we need a good explanation here to qualify for that 1 mark. 12, Patrick has to work out the exact value of 64 to the 1/4. And he says that a quarter of 64 is 16, which means that 64 to the 1/4 is 16. So we need to explain what is wrong with what Patrick says. Well, 64 to the 1/4 is the 4th root of 64. And my calculator gave me an answer of 2.8 blah, blah, blah. Okay? But a quarter of 64 is 16. So it's not a quarter times 64, it's 64 to the power of 1/4, and therefore the two are different. That's the mistake that Patrick did. 13, it's the density of ethanol, 1.09 grams per cubic centimeters. The density of propylene is 0.97. We've got 60 liters of ethanol with 180 liters of propylene to make 188 liters of antifreeze. We need to work out the density of the antifreeze. I think it's a good idea to start off by writing the formula for density. If you look at the units here, they always reveal the formula. Density is measured in grams per cubic centimeters, so density is mass over volume. So we'll work on ethanol, then propylene, and then the mixture, which is an antifreeze. So for ethanol, we have been given the density and the volume. So I will start by saying that 60 liters is 60,000 centimeters. Remember that 1 liter is 1,000 cubic centimeters. So 1.09 grams per cubic centimeters is the mass of ethanol over 60,000 cubic centimeters. I will cross multiply and I get that the mass of ethanol used was 65,400 grams. Let me do the same for propylene. So I will start by saying that 0.97 grams per cubic centimeter, the density, is the mass of propylene over the 120,000 cubic centimeters of that used. It's 120 liters. Again, multiply that by 1,000. Cross multiply, and you guess that the mass is 124,160 grams. So, all in all, for the antifreeze, we've got the total mass. So the density here will be the total mass, which was 65,400 plus 124,160, and all over the total volume, which was 60,000 plus 128,000. Just plug everything as it stands on the calculator, you get 1.008298. We've been asked to give our answer correct to 2 decimal places here, so it has to be 1.01 grams per cubic centimeter. 14, it's the diagram showing a rectangle ABDE, two congruent, which means identical, exactly the same measurements, triangles AFE and BCD. The area of the rectangle ABDE, So this here is the area of the triangle AFE plus the area of the triangle BCD. And we are told that AB to AE is 1 to 3. So I think it's a good idea to start off by calling this X. So if AB is X, AE is 3 times that is 3X. And I need to work out the length of AE. So I'm gonna use this relationship between areas, and we know that the area of the rectangle will be X times 3X is equal to the area of the two triangles together. The two triangles are identical, so it's just twice the area of triangle AFE. Now for AFE, I'm gonna stand on A and say it's a half, 24 times 3x times sine of 30. I'm using the a half AB sine C formula here. So a half times 24 times 3x times sine of 30. Now, if I do the calculations, I get 3x squared is equal to 36x. I just put 2 times a half times 24 times 3 times sine 30 on the calculator. So I will collect everything on the left-hand side. 3x squared minus 36x is 0. I will factor out 3x, x minus 12, which leads to x is 0 or x is 12. Now, obviously, x is 0 is not a valid answer, so I reject this. It's not valid. So we found x to be 12. Don't stop here. Always check on what the answer was, what the question was asking you to find. We had to find the length of AE. AE is here, so we're looking for 3x. So hence AE is 3 times 12, which is 36. So the answer is 36 centimeters. 15. The graph of the curve C with equation y is f of x is transformed to give the graph of the curve S with equation y is f of minus x minus 3. And we had a graph here, the point here, 7, 2, which is mapped to point Q. And we need to find the coordinates of Q. We really need to consider what exactly the transformations are doing here. We've got two transformations, f of minus x and the minus 3 outside. Now, the f of minus x is multiplying all the x's by negative 1. So if I had something here at 5, it will go at negative 5. If I had something here at 2, it will go at negative 2. So we've got this switch from left to right. So f of minus x is representing a reflection along the y-axis. So it's a reflection along y-axis, which means multiply x by minus 1. Now the minus 3 here means deduct 3 from the y. So it is a translation 3 units down. So, i.e. deduct 3 from y, which means that the point here, the 7, 2, well, I will multiply 7 by negative 1, leaving minus 7, and I will deduct 3 from 2, taking me to negative 1.
In 16, we have the first 6 terms of a quadratic sequence, and we're being asked to find the nth term of this sequence. Let me start by reminding ourselves that the quadratic sequence has the general term an squared plus bn plus c. So the way I approach this question is by drawing up a table. So the first row will be the values of n. So the first term, the second term, the third term, the fourth, the fifth. And then I'm going to put the nth terms. So minus 1, 5, 15, 29, 47. So In the first position, I'm going to find the number -1. In the second position, the number 5, and so on. I will start by drawing up the first row of differences. So I'm going to write down first differences. So from -1 to 5, it's 6. From 5 to 15 is 10. 15 to 29 is 14. 29 to 47 is 18. Then I go for the second row of differences, which is 4, 4, 4. And that's a property of quadratic sequences, that the second row of differences is going to be a constant number. In this case, it's 4. And actually, this constant number here will give me the value of a in the expression for the nth term of this quadratic sequence. So from the fact that a, the second row of differences, is 4, leads to the conclusion that a is 4 over 2, which is 2. In other words, once you get the second row of differences and you see the constant number here, divide that by 2 and you have found a. So it's going to be 2n squared plus bn plus c. I will start with the 2n squared. I'm going to put the 2n squared here. So when n is 1, 2n squared is 2 times 1 squared, which is 2. When n is 2, 2 times 2 squared is 8. When n is 3, 2 times 3 squared is 18. When n is 4, 2 times 4 squared is 32. And when n is 5, 2 times 5 squared is 50. Which means that if I have the 2n squared term, I'm already at 8, at 2, at 8, at 18, 32, and then 50. But I want to be at 1, 2, I want to be at -1, 5, 15, 29, and 47, which means from 2 to -1, I need to deduct 3. From 8 to 5, I need to deduct 3. From 18 to 15, I deduct 3. So I see I always have to deduct 3. So from 2n squared, if you deduct 3, you have found the expression for the nth term of this quadratic sequence is 2n squared minus 3. In 17, we've got 4 graphs, A, B, C, D, and we need to match them according to this table here. It says f of x is inversely proportional to x, which means that as x increases, y decreases, and it's graph B. Notice that as x goes to the right, as x increases, y goes down. So this is an inverse relationship between y and x, so it's a B. A trigonometrical function, it's this one here that creates a wave. So this is a sine graph, so that's a trigonometrical function A. An exponential function is one that increases. So from left to right we go up, so that's graph D. And directly proportional to root x must be the last one. C, the graph of root x looks exactly like graph C here. 18, we need to expand the triple brackets here. So I've got 2x plus 1 times x plus 3 times 3x plus 7. I will start by leaving the 2x plus 1 on its own there and expanding the other two sets of brackets here. So x times 3x is 3x squared, x times 7 is 7x, 3 times 3x is 9x, and 3 times 7 is 21. I will collect the like terms and then expand further. So it's 3x squared plus 16x plus 21. So if I expand now, 2x times 3x squared is 6x cubed plus 32x squared plus 42x plus 3x squared plus 16x plus 21. So I have done all the pairs, and then it's 6x cubed, 32x squared plus 3x squared is 35x squared, 42x plus 16x is 58x plus 21. And then in B, I need to solve this quadratic inequality, 1 minus x all squared less than 9 over 25. One approach would be for me to start by expanding. So 1 minus 2x plus x squared less than 9 over 25. I will collect everything on the left-hand side. So x squared minus 2x and 1 minus 9 over 25 is plus 16 over 25 less than 0. I could multiply everything by 25 to get rid of the fraction. So 25x squared minus 50x plus 16 is less than 0. And then I could actually factorize this into 5x minus 8, 5x minus 2. And from this, we can extract the critical values, the values that make the left-hand side 0. It's 5x minus 8 is 0, and 5x minus 2 is 0, which leads to x is 8 over 5, and x is 2 over 5. So if I was to actually sketch this quadratic, it would be something like this. Critical values are 2 over 5 and 8 over 5. It's a smiley parabola because the coefficient of x squared is positive, which means I go from positive to negative to positive, and we want it to be less than 0. So the y values are less than 0 here. I want to be between minus 2 over 5 and 8 over 5. An alternative was to just turn this immediately into an equation. So I could say 1 minus x all squared is 9 over 25. So 1 minus x is plus minus the root of 9 over 25, which is plus minus 3 over 5. This means that either 1 minus x is 3 over 5 or 1 minus x is minus 3 over 5, which means 2 over 5 is x or 8 over 5 is x. And these are the critical values. I would then draw again the number line. This is 2 over 5. This is 8 over 5. If I was to expand this, it's a positive quadratic. So once more, it's gonna go like this and then follow exactly the same approach I did before to end up with exactly the same answer of 2 over 5 less than x less than 8 over 5. 19, we're being told that d is u squared over 2a. U is 26.2 correct to 3SF and a is 4.3 correct to 2SF. And we need to calculate the upper bound for the value of d. Now, I always like to start by determining the upper and lower bounds of each quantity. 26.2 to 3SF means that the upper bound is 26.25 and the lower bound is 26.15. And for A, it's 4.3, which means I go from 4.35 to 4.25. Now, to find the upper bound for D, to make D as large as possible, I need to make U as big as possible and A as small as possible. So, the upper bound of D will be 26.25 squared over 2 times 4.25, which turns out to be 81.0662. We have been told to give our answer to 6SF here. And then the lower bound is 78.6003, correct to 6SF. By considering bounds, write down the value of D to a suitable degree of accuracy. Now notice that if I was to round the upper bound to the nearest integer, it would be 81, and this, it would be 79. They do not agree to the nearest integer. But if I was to round to the nearest first significant figure, it would have been 80, and this would have been also 80. So they agree to one significant figure to 80. So that's gonna be my answer. So write down the value of D to a suitable degree of accuracy. Well, both bounds round to 80 to one significant figure. Hence, it is certain that D is 80. Correct to 1SF. So since they agreed to 80, it's surely 80. I cannot be more precise in terms of a second significant figure or anything like that. 20, we need to solve algebraically the simultaneous equations shown here. So it's a quadratic and a linear equation. I will take the linear, 3x plus 4y is 7. And I will make x the subject, so x should be 7 minus 4y over 3. And I will substitute into the quadratic, so 7 minus 4y over 3 all squared minus 4y squared is 9. So I will expand this. 7 squared is 49. 7 times 4y is 28y, and I've got twice this cross product, so it's minus 56y plus 16y squared all over 9 minus 4y squared is 9. I will multiply throughout by 9 to get rid of the fractions, so 49 minus 56y plus 16y squared minus 36y squared is 81. And then I'll collect everything on the right hand side to make the leading term positive. 16y squared minus 36y squared was negative 20y squared on the left, so it's gonna go 20y squared on the right plus 56y, and then 81 minus 49 is 32. I will now divide everything by 4, leading to 5y squared plus 14y plus 8, which I will factor into 5y plus 4, y plus 2. So either 5y plus 4 is 0 or y plus 2 is 0. So this gives me y is minus 4 over 5 or y is negative 2. I haven't finished. I need to actually go and calculate the corresponding values of x. So x is 7 minus 4 times minus 4 over 5, all of it over 3, which turns out to be 17 over 5, or x is 7 minus 4 times minus 2 over 3, which turns out to be 5. So I'm going to write out the solutions carefully. X is 17 over 5, y is minus 4 over 5, or x is 5 and y is negative 2. always write down the pairs together.
Question 21, we've got the histogram giving information about the distribution of the weights of some onions. So we have weights from 0 to 180 grams, and we are told that anything less than 60 grams is used for pickling. Anything greater than 120 goes at the market to be sold, and the rest are used in a food processing factory. And if you turn the page over, it's got a pie chart drawn, and we are being asked to find the angle here. Now we know that this angle here corresponds to the proportion of the total that is occupied by this category, those onions that are sent to the food processing factory. So the idea is to use the histogram in order to find X. So we know that the fundamental characteristic of a histogram is that the area corresponds or is proportional to the frequency. So I will start by finding the area of all of these. So the first rectangle measures 60 by 2, so it's 120 onions here. Then it's 30 times 5, which is 150. Then it's 30 times 9, which is 270. Then it's 15, from 120 to 135, it's 15 times 6, which is 90. And then 45 times 2, which is 90. So this means that we've got 120 onions between 0 and 60 grams. We've got 150 onions between 60 and 90, and so on. And we're essentially looking at three classes, three categories. Those used for pickling are those that weigh less than 60 grams. So it's those 120. Those that are greater than 120 are sold at the market. So greater than 120, it's this part here and this part here. So 90 plus 90, which is 180. And the rest, which are sent to a food processing factory, which is the 150 and the 270. So we've got 150 and 270, which gives me 420. So if I add the 120, the 180, and the 420, altogether will give me the total. So there we go. Total is 120 plus 180 plus 420, which gives me an answer of 720. Out of these 720 onions, 420 of them are gonna be sent to the food processing factory. So to find the angle X corresponding to the sector of those onions that are sent for processing, well, X is 420 over 720 times 360, because angles in a circle add up to 360, and this is giving me an answer of 210 degrees. So that's the answer to this question. 22, it's a diagram showing a circle centered at O. We are told that AB is a tangent to the circle at point A. We have the angle there, the 30 degrees, and we've got the coordinates of B and the coordinates of P. We need to find the value of P. So I will start by drawing the radius from O to A. So the radius is obviously going to be called R, and we know that this angle here is a right angle because the angle between the radius and the tangent at the point of contact is always going to be 90 degrees. So we're essentially looking here at a right angle triangle. So I'm just going to highlight it so we can see it. There it is. So we can say that sine of 30 equals to opposite, which is R, over hypotenuse, and the hypotenuse is this here. Now this side here, the OB, is 16 units in length because it's just the x coordinate of B. So it's R over 16, meaning that 16 sine 30 is equal to R, which gives R to be 8. So we found R to be 8. We want to find the value of P, where P P is the point here with coordinates 3P and P. So what I'm gonna do is actually join O with P. We know it's a radius, it's 8 units as well. And if I drop the perpendicular here, I will see yet another right angle triangle. This side here is P and this is 3P using the coordinates of P. So I'm just going to apply Pythagoras theorem here and say that 3P all squared plus P squared is 8 squared. So 9P squared plus P squared is 64, leading to 10P squared being 64. So P squared is 6.4. I'm just going to take the square root of that. I will just consider the positive square root because I see that P is a positive value as the point P here lies in the first quadrant, and therefore this gives an answer of 2.5, correct to 1 decimal place as requested. And final question 23, we've got 3 towns A, B, and C. We've got different lengths, distances between the towns and some angles here. I need to find the bearing of C from A. I'm standing at A. I look at the north. I turn clockwise until I look at C. So I'm trying to find this angle here. That's the angle I'm trying to find. So I think it's a good idea to call this theta, because once I find theta, I'm going to be adding 37 and I will be done. Now, if we just look at A and B, we see that the norths being parallel, this angle here is interior with the 37. So this here is 180 minus 37, which is equal to 143 degrees. Which means I can use angles at a point and find this one here, which is 360 minus the 143 and the 150, which gives an answer of 67 degrees. So we've got the angle here. I'm trying to find this one here. I will start by using cosine rule to find AC. So the cosine rule, I always start opposite the angle I've got. So I'm gonna say AC squared is 8 squared plus 9 squared minus 2 times 8 times 9 cos of 67. I will plug everything on the calculator. I get that AC squared is 88.7347 ... I take the square root of that and I get 9.4199. I don't plan on rounding this answer. It's not a final answer, it's an intermediate answer. So I'm just gonna keep full accuracy for AC. So we know that AC is 9.4199. So I will now use sine rule, theta with 9 and 67 with 9.4199. So sine rule now will give me that sine of 67 over what I got for AC, 9.4199, is equal to sine of theta over 9. I will cross multiply the 9 sine 67 over 9.4199 is sine theta. And if I do shift sine of that, I will get theta to be 61.6 degrees. Remember, I'm not done. The question was asking for the bearing of C from A. So I will have to add the 37 onto theta to find the bearing. So 37 plus 61.6 is equal to 98.6. The answer has to be given to 1 decimal place. So it's going to be 98.6.